Hi GOH, this is the answers for the review sheet for Unit 8 Trig. So we're going over this in class and it's also printed, but I just wanted to go over it quickly with you if you had any questions. And there's also extra help on Friday at 9:40. So you can always pause this if you want to be able to, rewind it or play it again or anything like that, because I am going to go through it quickly. So the key on the first question is that the triangles are similar. Remember, if they're similar, their sides are in proportion. So I want to know which of the following is closest to the ratio of DE to DF. Well, DE is the left side and DF is the bottom. So basically I need the left side and the bottom of the other triangle because the sides will be in proportion. And 9/16, if you do that in your calculator, is just 0.56. Number 2, the triangles are also similar. So in 1, we use the word similar, and 2, we have the symbol for similar. And remember, if they're similar, their sides are in proportion. So you can see how I sort of highlighted in the same color the sides that are matching up to each other. The order of the letters tells you what side matches up to what. So if I draw a triangle HIJ, when I draw LMN, I should put the L in the same place I put the H, which was the bottom left. The M went at the top because the I went there, and the N went on the bottom right because the J went there. Number 3, given the triangle shown below with side marked, which of the following is the value of the tangent of G? So remember, tangent is opposite over adjacent. So from angle G, the 56 is opposite, and the 33 is adjacent. So choice 4. Number 4, I have a triangle WXY. W is a right angle. So I make sure that W is a right angle. The X and the Y don't matter if they're on the top or the bottom. WY is 15, so I put that on my picture. XY is 17, and WX is 8, and they want to know which is the value of the sine of Y. So if I'm basing this whole thing off of Y, this is opposite. Hypotenuse is across from the right angle, that's the 17. The side left over is my adjacent side. And I want to know the sine of Y, so sine is opposite over hypotenuse. So I use the 8 and the 17, choice 1. Number 5, I have a right triangle. Again, I would draw a picture for this. B is the right angle, so I make sure that B goes in the right angle position. A and C don't matter. And I want to know the cosine of A. Remember, cosine is adjacent over hypotenuse. So I need to put the 2, because cosine of A is equal to 2/3. I want to put the 2 in the adjacent spot and the 3 in the hypotenuse spot. And then if AB equals 24, then what does AC equal? Because remember, this is just a ratio, that 2/3. So now I'm setting them equal to what the actual sides are. So 2/3, AB is 24, and AC is the thing I'm trying to figure out, and then I just cross multiply to solve for that. So it's sort of combining what we know about trig with what we did in the similar triangle chapter last unit. Number 6, D and E are complementary. That means that they add up to 90 degrees. Which of the following statements is true? Remember, we learned the sine of A equals the cosine of B if A plus B equals 90. So if I know they're complementary, then that means the sine of one of the angles equals the cosine of the other angle. 7, I already had a picture, and I want to know what's the measure of angle L. So 6 is opposite, and 14 is hypotenuse, so I make sure that I use sine. Remember, you're going to write SOHCAHTOA across the top of your paper. So I'm doing sine of L equals 6/14. I don't have the angle, I'm trying to find the angle, and that's when I use that inverse button. So sine -1, 6 divided by 14 is 25.37. I have a 3, 4, 5 triangle. The 5 has to be the hypotenuse. I want to know the measure of the larger acute angle. The larger acute angle is across from the longer side, not the hypotenuse, one of the other sides. So the 4 is the longest side, that's not the hypotenuse. So the angle across from it is the angle that I'm trying to find. And then I can do sine of x if I wanted to. So I'm going to use the 4 and the 5 because they're opposite in hypotenuse. Sine of x equals 4/5. I'm trying to solve for x. X is the angle that I don't know, so I'm going to use that inverse button, and I get 53 degrees. In 9, I have triangle EFG, and I want to find the length of EG. EG is what I'm going to call x, and based on this angle right here, those two sides are adjacent and hypotenuse, so therefore I'm going to use cosine. So cosine of 38 equals x over 15, adjacent over hypotenuse. I put a 1 under there, and I just cross multiply. When you cross multiply, I have x by itself. 1 times x is x. And cosine of 38 times 15 goes in my calculator, and I get 11.8. 10, I'm going to put the information on my picture that's not there. And actually, the only thing that's not there, I want to find the length of JK. So I'm going to call that x. This is my hypotenuse. This is opposite because my angle is 25 right here. So since I have opposite and hypotenuse, I will use sine. So sine of 25 equals 40 over x. Put a 1 under there and cross multiply. Now when you cross multiply, you don't have x by itself, so it just takes one extra step to solve for x. I'm going to divide by sine of 25. So in my calculator, I'm putting 40 divided by sine of 25. And actually, I don't even have to do it because look, that's my answer right there, choice 2. 11 wants me to find the missing side of that right triangle. So when I know two sides, and I'm trying to find the missing side, that's when I'm using Pythagorean theorem. So x squared plus 35 squared equals 37 squared. You can see I did that out. I'm going to subtract, and then I take the square root of 244 is 15.62. And then I want to state the following values. So I'm just doing each one. So I'm doing sine of c. So if I'm doing sine of c, this is opposite. This is hypotenuse. And this is adjacent. And that again is the 15.62 that I just found out. So sine is opposite 35 over 37. Tangent of c is opposite 35 over adjacent 15.62. And cosine of c is adjacent 15.62 over hypotenuse 37. Then they want me to find the measure of angle A to the nearest degree. So I just did cosine. So this is A. So I decided to use cosine. And actually when I'm doing A, this 35 is not opposite anymore. It's adjacent. So that's why I'm doing cosine. So I'm using the 35 and the 37, but they're opposite. They're adjacent and hypotenuse. So therefore I'm using cosine. I don't have the angle, so that's why I'm using that inverse button. Number 12. Angle A and angle B equal 90, so that makes angle C the right angle. The sine of A is 7 over 12, so based on angle A, and I'm talking about sine is opposite, so I'm going to put 7 in the opposite position, and I'm going to put 12 in the hypotenuse position. Then they want to know the value of cosine of B. Well, cosine of B is adjacent over hypotenuse. Look, it's the same exact thing. And that's true because remember we learned sine of A equals cosine of B. 13 is just a trig problem, so that angle of elevation is 12. Remember the angle of elevation always goes in the bottom corner there. And I'm trying to find out the distance from A to B. This is adjacent and this is opposite, so therefore I am using tangent. I set up my trig. Tangent of 12 equals 1063 over x. Put a 1 under there and cross multiply. And solve for x, and I get 5001. 14 is a little bit trickier. I'm going to solve these triangles. That means two sides are congruent. The legs are 10, and the base is 4. All right, so these legs are congruent to each other. Now I'm talking about finding the measure of one of the base angles. So I can't use trig unless I have a right triangle. So all I did was I drew the altitude in this isosceles triangle, and the altitude cuts that base in half. But now I have a right triangle, and I can use trig on that right triangle because I'm trying to find the measure of one of those base angles. So cosine of x, that's the angle, equals 2 over 10 because this was adjacent and this was hypotenuse. So that's why I'm using cosine. I don't have the angle, so I'm using that inverse button. right? And I get 78 degrees. 15, I have a skier, and she has a vertical drop of 92, so that's why I put 92 on that vertical line. The angle of elevation is 36, that's in the bottom corner, it's already on the picture, and I'm trying to find the distance she travels from point A to point B. Well, based on that angle of 36, the 92 is opposite and the x is hypotenuse, so therefore I'm using sine. So sine of 36 equals 92 over x. Put a 1 under there, cross multiply, and I have to solve for x, so I have to divide by sine of 36, and I do get 157. 16 already has the picture, and I'm trying to find that angle of inclination. That's the angle, that's sort of like the angle of elevation in that bottom corner there. All right, and I'm going to use tangent because this is opposite and this is adjacent. So tangent of x equals 2.5 over 6. And then to solve for x, I'm trying to find the angle. I have to use that inverse. So tan negative 1, 2.5 divided by 6 is going to be 23 degrees. 17, I have a 14-foot long bridge, and the wire makes an angle of 27 degrees, and I'm trying to find the length of that wire. So I have hypotenuse and adjacent, therefore I'm using cosine. So cosine of 27 equals 14 over x. If you're having trouble, make sure that you're labeling the sides of the triangle with hypotenuse, opposite, adjacent. Decide if you're going to use sine, cosine, or tangent. And then you're really just setting it up and cross multiplying and solving for x and using your calculator. All right, 18 is definitely a little bit trickier. You basically have two right triangles. I want to find the length of AC. So I'm going to find the length of AD and I'm going to find the length of CD, and I'm going to add them together. So I did those in two different colors. First, I want to know what other angle in the diagram is equal to 32, and that's going to be angle ABD. So you got to remember that there's three. The outermost triangle, if this is 90 by angle B and angle C is 32, that means this is 58 up there. And then looking at that green triangle, this is 90 and that's 58, then angle ABD is 32. As I said before, you're going to do one trig ratio to find x. So I did that in red to find CD. All right, based on this angle of, what did I use? I guess I used the 58. All right, and this is opposite and this is adjacent. So that's why I use tangent. So tangent of 58 equals x over 16. I just cross multiply and solve. And then in blue, I was trying to find AD. I called that y. And again, I used the 32. So tangent of 32 equals opposite over adjacent, y over 16. And again, I'm just cross multiplying and solving. And then all I did was take x and y, and I added them together because I was trying to find the length of AC. So that's 35.6. 19, you had to draw your own picture. I have a ladder. So remember, my ladder is my hypotenuse. It's 10 feet. It reaches 8.25 feet up the side of a building. So that's that vertical line right there. And I'm trying to find the angle that the ladder makes with the ground. That's my x. So I do have opposite and hypotenuse, which is why I use sine. So sine of x equals 8.25 over 10. And I'm trying to find the angle, so I have to use that inverse button on my calculator. 20, I have the angle of elevation of a soccer ball. To the top of the goal is 34, so I draw my right triangle. Angle of elevation goes in the bottom right corner. The goal is 8 feet tall, and I want to know the distance of the ball to the goal. So that's adjacent, and the 8 is opposite. Therefore, I'm using tangent. So tangent of 34 equals 8 over x. Again, cross multiply, solve for x by dividing by tangent of 34, and I get 11.9. 21, I have a Ferris wheel, and the angle of depression is technically outside of the triangle. But remember, we mentioned if they're alternate interior angles, I can just put it in the bottom corner where the angle of elevation also goes. Your friend is 30 feet from the foot of the ride. The foot of the ride is the bottom of the ride. That's, your feet are on the bottom of your body. How tall is the Ferris wheel? Your height is always going to be that vertical line right there. So again, I have adjacent and opposite, which is why I use tangent. So tangent of 61 equals x over 30. And I just cross multiply. And I solve for x. And I get 54.1. 22 is definitely a little bit harder to do. I did it two different ways. Some of you actually did it the second way. I think it's easier to do the law of sines. You won't have something like this on your test, but I did make up an additional problem if you want to look at that you will have on your test. But I basically used, I found the missing angles. So if this is 25.8, I subtracted from 180 to get 154.2. So remember, this is the angle and this is the side. So these guys, I'll highlight them so to match up with each other. I'm going to use law of sines. And then if I know that bottom angle is 20.7, then that leaves 5.1 for the top. And these, oops, I should take a different color. These guys match up with each other. This and the 320. All right, so I'm using law of sines to help me find x, which is 1566.736. And then once you have that, then you can do a regular trig equation with the outermost triangle right there. Again, using the 20.7, but then this is going to be opposite and this is going to be hypotenuse. So you can't use basic trig because you don't have enough information, but I use law of sines with this other triangle that's not a right triangle out here, and then I can use that basic trig, and I get my height is 554. The other way to do it is if I wanted to call this y right here, b, well there's no other letter, but this segment right here is y, then that whole segment is 320 plus y, and you can set up two separate trig ratios, all right, with each of the triangles, and then you're using substitution, all right? And you're basically solving for h for each one, and since they're both in terms of h, you can use substitution. And after you do all that, and you've bring everything with the y to one side and factor out that y and divide by that, then you finally find out what y is, and then you can use that to find h. So definitely a tricky problem. It was a Regents question. It was a part 4 question. All right, I won't ask anything that tricky, but remember we did something like this, so I just made this up right here. If you wanted to try it, I give you these two angles. I'm trying to find the length from C to D. So remember, I really find BD, and then I find BC, and I subtract them. So I do two different trig ratios. They're both going to be tangent because they're both, it's going to be opposite and adjacent. And I find each one and then I subtract them, and that would give me my length of CD. All right, so I can't find CD directly because CD is not part of a right triangle, but BD is part of a right triangle. I use tangent. And BC is part of the smaller right triangle. I use tangent, but with the other angle, and then I just subtract them, and there's my answer, 352.67. All right.